Hello and welcome to another CS Tutor Center video. Today we're going to talk about the problem, find the duplicate number. But before we get started, if you're liking these videos and you would like me to make more of them, please subscribe to the channel. When you subscribe to the channel, it lets me know that you would want me to make more of these videos. Alright, let's get started. Given an array of integer nums containing n plus 1 integers, where each integer is in the range from 1 to n inclusive, there is only one repeated number in nums. Return this repeated number. You must solve the problem without modifying the array nums and uses only constant extra space. So let's look at this example down here. So this example down here has 1, 2, 3, 4, 5. So it has 5 elements in this array. And we can see that when we look at the constraints, the length of this array is equal to n plus 1. So that means that n is 4. So if this is 5, n would be 4. 4 plus 1 would be 5. So the range that these values can be for this example would be between 1 to 4 inclusive. So we see those values, they choose the numbers 1 to 4 inclusive, and it's guaranteed that there'll be only one repeated number, so we see that the repeated number is 2. Let's look at this one. We have 5 elements in it, they do 1 to 4, the repeated number is 3, so we return 3. Let's look at the constraints. N can be between 1 to 10 to the 5. At nums.length is equal to n plus 1. The number inside at location nums of I can be between 1 to n inclusive. All the integers in nums appear only once, except for precisely one integer which appears 2 or more times. Okay, let's hop over to the blackboard. Okay, here's an example for the problem. And what we're going to do is we're going to see how we'll be able to find the duplicate number. Here in the example, we can see that the duplicate number is 3, but how is that going to work? Well, I'm going to say first off, we're going to use something called the Floyd's algorithm. So okay, and the Floyd's algorithm is useful to do many different things. Some of the things you can do is detect if there's a cycle in a linked list. And you can also use it to find the entry point of that cycle. Okay, so we're going to make use of these two things to solve this problem. We'll actually have to do both of those things to solve this problem. So when we look at this, if I draw it out, it'll be more intuitive where the cycle begins inside of the entry point of that cycle. So I'm going to draw this out. So here's what we'll do when we draw it out. Here's how I'm going to represent that. Let me I'm just trying to move this. All right, so what we'll do is we'll start out, we'll run through this real quick, and then I'll draw it out. So put it up here, so put it down here. Well, that thing pops up, so I'll put it up here. All right, so we'll start out at location 0, and one thing we know about location 0, the reason why we're going to start there is because our bounds is between 1 to n, where n is where the nums.length is equal to n plus 1. So notice that there's no 0 is not in this range. Notice that. So because 0 is not in this range, we know 0 cannot be inside of the cycle. Or because we're never going to go back to 0. Like when we pick the numbers here, 3, 1, 3, 4, 2, 4, these are the numbers that are going to tell us what index to travel to. But 0 is not a number in the range, so we'll never have 0 as a number to travel back to. So we can safely start at 0 for our algorithm here. That's the starting point. All right, so what we're going to do is when we start out at 0, we're going to read 3. So when we read 3, we'll put that in this box here, 3, and then I'm going to put the index of where we read that from down here, so 0. Okay, and then I'll have a arrow here to go to the next one, and I'll make this a nice bright color, and we'll go to the next one. Okay, so now it says, so we are at 0, we read 3, okay, and so when we read 3, we're going to go to index 3. So here's index 3, so we'll make this. Actually, I'll just copy this here. Oh, that didn't work. Okay, so we started out location 0, we read 3 at location 0, so it says go to index 3, we went to index 3, and we read 4. And when we read 4, we go to index 4 and read 2 from index 4. And then just going to copy all these at the same time. Then we go to index 2, which is 3. So actually, now we are in our cycle. So I'm gonna I'll move this up here like this. Let's see, we read 2, so it says go to 2, which is location 3. So and that actually, hang on one second. So we're at 4, we read that, we go to 2, which says go to 4. So we go to 4, which is reads 2, and that takes us to 2, which is 3. So this would be like this. Three at location 2. And then now at location 2 we read the 3, so then that says go to location 3, which is the 4. So copy this here. Actually, I'll just... Okay, there we go. So let me try to... Well, okay, so it's not the prettiest cycle, but we can see here where the entry point is. It's at this point right here. That's the duplicate number, 3. So first we got to detect that there's a cycle, so we'll figure out there's a cycle, and then we got to figure out the entry point. Okay, so inside of this algorithm, the reason why the entry point is the cycle is, I'll show you why. So you'll see the reason here. So first I'll draw this arrow, and I'll change this color. Okay, and then we'll call this like X. And then, actually, yeah, it's fine. And then now we have the distance that goes around this part. So that distance is going to go from here all the way over to where actually we gotta do the algorithms to see where we found the cycle. So let's do that real quick. So um, here's how the cycle, figuring out the cycle works. So inside this Floyd algorithm, we create 2 pointers. So one pointer is a slow pointer. It's not going to travel as fast. And then another pointer is going to be a fast pointer. It's going to travel twice as fast as the slow pointer. So we start them both out here. It should be at this location. So I'll do it over here too at the same time so you can see it. So they both start there, and then we move them. So the fast goes, so we read the 3, it goes to location index 3, and then we read the 4, and then it goes to location index 4. And then this, so that travels twice, and this travels once. So it goes to location 3. Okay, here's what that looks like graphically. So we went with the fast one here, and then up here, and then the slow one went like this. I'll put them up there. Okay, now they're not equal to each other. If they were equal to each other, like on the same index, then that's when we detect that there's a cycle. Because if you picture people running, like if someone's slow and the other person's way fast, like they're when the fast person goes in here, they're going to be going around and around and around because there's a cycle, and the slow person will eventually get into this cycle, and it's just a matter of time before that fast person laps that slow person. So once they lap that slow person, once the fast person and the slow person cross each other, when they equal each other, then you know that there's a cycle. So just a matter of time. So we'll continue on and see that. So we read the 2s, the fast goes to the 2 index, and then we read the 3, and the fast goes to the 3 index, and then the slow moves up 1. So the slow moves up here. Let me write down the code so far of what we're doing, because you saw just there, you saw like, wait a second, they were on top of each other. Why didn't you stop? Well, the reason why is because you'll see in this algorithm, it's where we check it. Each loop, they both move, and then we check at the end. So that's going to start out at location like that, and then let's say we say do, and then we'll have a while. Slow does not equal fast. Okay, so then the slow equals the nums of slow, and the fast equals the nums of fast, and I'm going to draw it like on 2 lines, so it's just more clear than doing it on 1 line, where you could reduce this down to 1 line. Okay, so here we are. So we see that this is what we're doing. So in that scenario back there, where the slow was on top of here, we had done let me move this down here to fit the way I've been doing it. We just did the fast ones, and then now we're going to do the slow ones. So the slow one moves to where the 4 is. Okay, now we check. Is the slow and the fast equal to each other? No, they're not. Okay, so, and then we replicate it over here so we can see it graphically. So this goes twice, and this goes once. Okay, and then we're going to do this again. So the fast goes twice to the 4, to the 2. The slow goes once to the 2. And then we check, and there the loop ends. Okay, so here we go. We replicate it over here. We'll do it again over here. This one, that one, and then this one. Okay, so they equal each other, so that ends. So now here we are. If we are solving a Leetcode problem that said detect a cycle in a linked list, there would be a cycle now if S equals F, right? And in our code here, it would never, there would be an infinite loop if it never did equal each other. And that's okay because in this problem, it's guaranteed that there's going to be a duplicate. So it's guaranteed that there's going to be a cycle. So we know that we're going to get to the point down here where we will finish this loop and S will equal F, and that's where we find the cycle. All right, so that's this first one here, detect the cycle. So that's our first time that we intersect. The second time that we intersect is going to be when we find the entry point of that cycle. That's right here, this one, which is the duplicate number. So here's how we're going to find that. What we're going to do is we're going to send this fast pointer back here. And you can do that, or you can create another variable because we're not going to make this go fast, so it's kind of doesn't really fit the naming anymore. So why don't we do this? Why don't we, that's there, doesn't matter. We'll create another one called like slow 2, okay? And they're both going to move one at a time. Okay, so this moves 1, and that moves 1. Now, when that's the case, that's where we find the entry point of the cycle, and that's where the duplicate number is. I'm going to explain how we know that in a second here. So we have S2 equals 0, and then we'll say, we'll just do this, while true. This is another way you could do it without a do while. While true, S equals nums of S, S2 equals nums of S2. If S equals S2, break. Okay, and then the result now is that the answer is going to be your S2. That's where the duplicate number is, 3. So how did we know that? Well, I'll show it, and then there's a way you can prove it mathematically. And if you guys want me to prove it mathematically, then just write in the comments and ask me to make another video to prove it mathematically. Okay, so it's good to know the proof. Just let me know if you're interested, and I'll make it if you are. All right, so let's look at this. Let's look at the distances here. Okay, so that's one distance, and then we're going to have another distance. Fortunately, I can't really draw like a circle around this thing. That's what I want to do. I want to draw a distance from here to, well, I guess this is fine. There's another distance. Let me make this a different color. Okay, there's that distance, and then now there's this distance between here, right? Well, oh, I want to do one more distance that goes around this whole loop, but I don't have that ability on this tool. So let's say this. Let's say we have let's say that x equals the green one, right? y equals the yellow, and then k equals the distance of actually, yeah, let me change these variables here. Call this m and n, and then k will be the distance do this. Say that n is going to be the distance of the cycle, and then k will be the distance from entry point to intersection. Okay, so k is the distance from the entry point, which is here, to the intersection, which is there. Okay, and then so I'm trying to do with this yellow thing here, but that doesn't really work so great. And then m is the distance from here to here, and then k is the distance of this whole circle. So if you were to look at this and you took, if you took this whole circle, and you subtracted off the yellow, then you would be left with this one here, right? And hopefully you can see that. Let me try to do this. It'll make it look a little bit better, I think. Keep on. Sorry about that. Okay, there's the distance from the entry point to the intersection. That's the first intersection. And then n is going to be the distance of the whole cycle. So try to do, I can make this work. So we'll have, that's going to make it too messy. Just, this is the cycle distance here, which is the k. So if you were to take this, if you were to take this m, okay, this part right here, and you, sorry, gosh. If you take this cycle here, take this cycle, and you just subtract off this yellow part, then you're left with this, right? And that distance here is the same distance as this distance here. So if you start at the beginning and you go the distance, that is the same, if you travel the same distance as the distance of the cycle minus from the entry point to the intersection, you're left with the same distance. Which, so that's where you end up finding out. So you have your, that's where you end up finding out the second intersection point. And that is your entry point of the cycle. So that's you can kind of visually see why the distance from here to the entry point is going to be the same distance as the distance from the first intersection to the entry point. So you can kind of visually see that. But there's not, you probably don't have confidence that that's always going to be the case yet, because we haven't done the math proof on that. And when we do the math proof on that, if you want me to do that, let me know in the comments and I'll do it, and then you'll see that that's always the case. And because that's always the case, then you know if you were to put a variable here at the beginning and it traveled one at a time, and this traveled one at a time, then they would both overlap at the entry point of the cycle. And the entry point of the cycle is a duplicate number. And so that's why this works. Okay, let's go code it up. So we'll hop over to Leetcode, and we'll start with the Java, and then we'll do the Python. All right, so first off, we'll do our slow equals 0, and we'll do our fast equals 0. And then I'm gonna, instead of doing a do loop, I'll do it like this. So we'll say slow equals nums of slow, and then fast equals nums of fast, and then fast equals nums of fast. And then if slow equals fast, then break. Okay, now I was saying earlier that we could reduce this down to one line. I'm going to do that now. So we'll reduce this down to one line. Same code, just it's on one line. Okay, so now that they overlapped each other, we broke out of that, and that's when we detected that there's a cycle, and there's guaranteed to be a cycle. And then next we have our S2, which is going to be 0, and then while true, we'll say that the slow equals nums of slow, and then the S2 equals nums of S2. Why don't we just make it say slow 2. Okay, and then if slow equals slow 2, then we break. And this is guaranteed to happen too because the problem says it's guaranteed that there's going to be a duplicate number. So we're going to find that entry point because that's guaranteed that there's a duplicate number. And then we return slow 2. So we'll run this. So that passes, and then we'll submit it. And then that's accepted. Okay, so now we'll hop over to the Python code, and we'll write that. Okay, so we have slow equals 0, fast equals 0, and then we'll say while true, and then we'll say slow equals nums of slow, and then we'll say fast equals nums of fast. And if you're just joining here at this point, here's another way you can write it, but I'm going to reduce it down to one line. So instead of this, I'm going to do this. Okay. And then if slow equals fast, then we'll break. And that's guaranteed to happen because the problem says that there is guaranteed to be at least one duplicate number. So we're guaranteed to have a cycle. So when we have a cycle, this will be the case and it'll break. And then now we're going to have slow 2 equals 0. And we'll say while true, and then slow equals nums of slow, and slow 2 equals nums of slow 2. And this is also guaranteed to happen because if we have a cycle, then we'll find the entry point. This is going to find the entry point of that cycle, which is where the duplicate number is. So, and that duplicate number is right where both slow and slow 2 are sitting. And so we just return slow 2. So, or you could return slow, either one. So we'll run this, and then we'll submit it. Great. All right. So thanks for watching. If you like this video and you want me to make more of them, please subscribe to the channel. And then when I see that you subscribe to the channel, that will let me know that you want me to make more of these videos. Have a good day. All right. Thank you. Bye.